Okay, we're back here for section 2 of today's lecture. Let's talk about a coupon bond. All right, how do you calculate the yield to maturity on a coupon bond? As I said before, coupon bonds are typically the way that corporate bonds are structured, right? And so what a coupon bond is you pay a price for an instrument that has a face value, usually in some increment of $1,000, right? It has a face value and it has a stated coupon rate. And every period you get an interest payment, right? Which is basically the interest rate times the face value. And then at the end of the maturity of the bond, at the end of the bond, you get your last interest payment and then you also get the face value back. Coupon bonds tend to pay interest twice a year. In other words, they tend to pay interest semi-annually. So let's work through an example here of working on a coupon bond. Right. So here's our example. What's the yield to maturity on a coupon bond that has $1,000 face value and a 10% coupon rate, that's the stated rate, and it has 10 years to maturity, but you only pay $900 for it, okay? Remember, coupon bonds pay semi-annual interest, right? So half of the annual coupon payment every 6 months. Your book actually ignores this fact. I've never really quite understood why your book ignores this fact. So if you look at your book, you'll see that how I have this equation set up is slightly different because your book acts as if you only make one interest payment a year. In fact, you make two. So how do we calculate the yield to maturity? Once again, what's the interest rate that equates the current price with the present value of future payments? What's the current price? We pay $900. What's the present value of future payments? Well, this is a little bit more complicated. Remember, every 6 months, you get half of the annual coupon rate. So if the face value is 1,000 and the coupon rate is 10%, that means that every year you get $100, or every 6 months, you get $50. So after 6 months, you get $50. How do we discount that back? Here, we discount that to 0.5 periods. And we account for the fact that this interest rate here is not the annual interest rate, it's just the 6-month interest rate, right? Because we usually think about yield to maturity as an annual basis, but here that return is only for 6 months. So we also have to adjust the interest rate here for the fact that this is half of a year, right? What happens then 6 months later at the end of the first year? Well, then we have another $50 payment. Here we discount it back by a full year, not half of a year, but a full year. And it's 1 plus I divided by 2 again. What happens in 18 months? We get another $50. We divide it back by a year and a half. All the way out to the end of 20 years. Right? Actually, I'm sorry, I have this wrong. This should not be 20, this should be 10, because I said originally, sorry about that, said originally that this was a 10 years to maturity. So there's going to be 20 payments, right? Because half a year, but it's only 10 years in the future. So my bad, typo. So what happens in this last payment? You not only get your last coupon payment, but you get the face value of $1,000. So notice here how you only paid $900, but you actually get an extra payment here at the end, an extra, you get more than what you paid for. You get the full face value here at the end, plus the last $50 of coupon payment. You divide that back by a full 10 years, okay? So that's how you set up the yield to maturity. What's the I then? I is the, by the way, I keep on making mistakes. That should be a 2 here too. Apologize. All right. So what's the I here? The I here is the annual yield to maturity, not the semi-annual, but the annual yield to maturity. How do you calculate this from this equation? Well, it's just like the fixed payment loan, you can't calculate this by hand. You have to use a financial calculator or some other program to calculate this. And so if you do this, and for homework number 1, which I've given you, I actually give you a link to an online financial calculator that will help you calculate a semi-annual coupon bond. And what you'll find here is that the interest rate that makes this true is 0.1175 or 11.75%. Now, what does this example tell us? How is it that this bond is giving you a return of 11.75%, but the interest rate is 10%? Sorry, the beeps, emails will keep on coming in. How is it that this has a yield to maturity of 11.75%, but the interest rate is 10%? That is because the price is less than the face value. You're basically buying this bond at a discount. And so whenever the price is less than the face value, which is true for this bond, the yield to maturity is greater than the coupon rate. Vice versa, what happens if you sold the price at the bond was selling at a premium? In other words, the price was greater than the face value. What that means is that the yield to maturity then is less than the coupon interest rate. And then of course, if the price is equal to the face value, then the yield to maturity would be the same as the coupon rate. Okay, sorry. I keep on seeing my video here, and for whatever reason, it seems very dark, but you don't need to see my face anyway. It's probably better you don't. All right, so the key to understanding all this is that the true price of a bondholder is willing to pay is not just based on the things that are stated on the bond, right? You can't tell what the yield to maturity is only by looking at the coupon rate and the face value. You also need to know what the price is. And the price is a function of what the bondholder thinks is the appropriate interest rate when discounting the bond, right? And so, in other words, yields can be greater or less than the coupon rate of a bond. Just to give one example here, here's the yield to maturity on a 10% coupon bond rate, right? So basically the bond that we just looked at. And you can see how as the price changes, the yield to maturity changes quite a bit. If the bond is selling at a premium, right? If the face value is 1,000, but it's selling at 1,200, the yield to maturity is only a little bit over 7%, even though the coupon interest rate is 10%. Down here, if you see that the bond is selling now at a discount, it's selling at only 800, the yield to maturity actually goes all the way up to 13%, right? So what this little example tells us is it explains the law of the bond market. And the law of the bond market is when interest rates rise, prices of bonds must fall, all right? That is the law of the bond market. Whenever yields rise in bond markets, prices must fall. Why? Because they're the flip side of the same coin, right? To get the yields to go up, the bond prices have to go down. When bond prices go up, yields have to fall. And it's just simply a reflection of these yield to maturity equations that we've been calculating. How about a discount bond? Let's talk about our last kind of asset here, a discount bond. So this would be basically a treasury bill, right? And remember the thing about a discount bond is that they don't make any interest payments. Instead, they always sell at a discount. They always sell at a price that's less than face value. And so it's that difference that is your return to holding a bond. So what's the yield to maturity on a $1,000 face value discount bond that has 100 days to maturity, right? Selling at 950. So here, because we're talking about T-bills have short-term maturities, right? The longest maturity of a T-bill is going to be 1 year. So usually when we talk about T-bills, we're really talking about days to maturity. And so calculating the yield to maturity here, we really have to express this in days. Now, here's one of the interesting things about calculating these yield to maturities. For whatever reason, I don't understand it. Maybe I should have done a Google search on this. Maybe I will when I'm done with the lecture here. But the market uses a 360-day year, not 365 days. And like I said, I don't know why this is, but this has always been the case, that they use a year, meaning 360 days. So what we have to do here is we have to calculate the present value, future value, based on how many days, right, till maturity. Once again, to get the yield to maturity, we set the current price, which is $950, equal to the present value of future payments. What's the present value of future payments? Well, in the future, you're going to get $1,000 100 days from now. So how do we discount that back? Well, here it's 100 periods, but notice here that we use this per day, right? So it's 100-day periods, right? So the interest rate here is divided by 360. So when we calculate this I, right, what we're really calculating is the annual rate, but recognizing the fact that an annual rate has 360 periods in it, right? So we have 100 days till maturity. We need to calculate the I in this equation that makes this true, right? Once again here, notice that the law of the bond market holds. What happens when yield to maturity goes up? The bond price has to fall, and vice versa, right? There's an inverse relationship between the bond price and the yield to maturity. This you can calculate by hand, right? So here you don't need a financial calculator. You can just use a regular calculator and calculate this by hand if you choose to do. And in fact, I'll ask you to do that on your homework number 1. Okay, so that's yield to maturity, right? One more time. I feel like I've said this 100 times already, but yield to maturity is the interest rate that equates the current price with the present value of payments. So you have to know how to set up this equation, right? You have to know how to set up the equation that equates the current price with the present value of future payments. Once you get the equation set up, then, you know, for the most part, you can just use a financial calculator to actually solve for the solution. Now, that's not the only measure of return. Yield to maturity is probably the best measure of return, quite honestly, right? But there's a couple of things that we should note about it. One of the things is it assumes that you're going to hold the bond till maturity. It is your yield till maturity. So if you are going to hold the bond until it matures, it is the best measure of your true return. But that's often not the case, right? Oftentimes people will buy a bond knowing they're not going to hold it till maturity. They're going to hold it for a period of time and then turn around and sell it. So in that case, you might be interested in looking at other measures of return. And so let's talk about a couple of other measures of return here. Okay. One other measure of return is called the current yield. The current yield is often used simply because it's easy, right? It's not particularly accurate, but it's easy. And what the current yield is you just take the yearly coupon payment and you divide it by the price, right? So whatever you get paid a year, you divide it by the price. If thinking about the coupon bond that we worked through a couple minutes ago, if you remember, the yearly coupon payment was $100, the price was $900. And so you just divide 100 by 900, and that gives you the current yield, which would be 11.11%. So if you think about what the current yield is doing, is it's really ignoring the difference between the price and the face value. It's ignoring the fact that you get an extra return on this bond, because in the end, you don't just get your price that you pay back for it, you get the face value. So it's ignoring the fact that price is different from face value. So this can actually be a pretty good approximation of yield to maturity if there's a long time for maturity, right? Because that difference in price and face value, you actually don't receive that difference until the end of the bond. So if that bond is 20, 30 years off, that difference in price is going to be a small part of your overall return. And so current yield is going to be pretty close to yield to maturity. Or if you buy the bond at very close to face value, yeah, current yield is going to be not too bad estimate of yield to maturity. And so, use current yield sparingly, but there are times that you can use it, right? If you see that a bond is selling close to face value, yeah, current yield is going to be a pretty quick down and dirty estimate of what that yield to maturity is. The other thing, the other measure of return here is the yearly return. And this is a more useful measure of return, particularly if you're only going to hold the bond for 1 year, okay? What is your return on holding the bond for 1 year? Well, first, you're going to get that coupon payment, and you can express that relative to the price that you paid. Notice that this first part of your yearly return is just the current yield, right? But the other part of your return is what happens if the price changes, right? So I might buy the bond at the beginning of the year at one price, but at the end of the year, there might be a much different price. So this second part of the yearly return is the percent change in price. We often will call this the capital gain or the capital loss, right? So if the price of the bond changes, that also is going to impact your return. Together, these things give you the yearly return, right? What we'll call IYR, right? So once again, what is the yearly return? It's first your current yield, which is based on your coupon payment, and then it's any capital gain or capital loss that you incur from the price of the bond changing. Now, here's the key point. Many people think that bonds are safe, right? Because bonds guarantee you a return. That is not true, right? Bonds do not guarantee you a return, particularly if you do not hold the bond till maturity. If you buy a bond today and then yields go way up and the price of the bond goes way down, and then you have to sell the bond, you could experience a very big capital loss, right? You could actually get a negative return on the bond. There's no guarantee that you will get a return on holding a bond if you can't hold that bond till maturity. So just to kind of see this in practice, look at here at table 2. This is from your book. This is looking at the 1-year return on different maturities for a 10% coupon rate when interest rates rise from 10% to 20%. So that's a big jump in interest rates. But look at the size of the capital gains, right? So let's say you have a 30-year bond. The current yield is 10%, and the initial price you bought it as is $1,000. But then what happens when the interest rate rises from 10% to 20%? That price is going to fall to 503, from 1,000 to 503. What's your capital loss going to be? Almost 50%. And so even though you got a 10% return from the coupon rate, if you add that 10% return with the almost 50% loss, notice that you lost almost 40% of your money, right? So yeah, right? This is what we call interest rate risk. When you buy a bond, you are vulnerable to capital gains and capital losses if you have to sell that bond before maturity, right? If you have to sell that bond before maturity, you could take big capital losses. Notice here, though, what happens to that interest rate risk? It gets smaller as the maturity goes down. Why? Because basically, you're going to get a smaller change in the price from any change in the yield, right? So let me say this again. For a long-term bond of 30 years, what happens if the yield changes? The price is going to have to change a lot to accommodate all those years on which now the yield is going to have to be different. But if it's just a 1 or 2 year bond, you're not going to have to change the price nearly as much because there's not nearly as many years that you have to adjust the return, right? So you'll see here that, for instance, a 2-year to maturity bond is going to have a very, very small rate of capital loss compared to a 30-year bond, right? And so this is one of the big risks of holding bonds. I'll just jump to point 3 here. One of the risks of holding bonds, and I think this is not often understood by people is interest rate risk. When interest rates change, bondholders can experience capital gains or capital losses. And this is bigger interest rate risk for long-term bonds, right? Longer-term bonds have more interest rate risk. Longer-term bonds have more interest rate risk. As we're going to talk about here in a moment, this is one of the reasons why longer-term bonds usually pay higher interest rates than short-term bonds, because they are risky, right? So we know that one of the fundamental concepts of finance is risk and return. Higher risk, you demand a higher return. Well, long-term bonds are higher risk than short-term bonds, and so long-term bonds typically pay a higher interest rate than short-term bonds. It is a risk premium, right? There's a risk premium to get people to hold long-term bonds. You have to pay them a little bit higher interest rate. So interest rate risk is a big part of the risk of holding bonds. In fact, for those of you who are investors, one of the things that you'll see is that bond market funds spend a lot of time thinking about managing interest rate risk. How, if we look at the portfolio of all the bonds that we hold, how many of them should be short term, how many should be medium term, how many should be long term? So for instance, Vanguard, who's a very popular mutual fund, they offer some bond funds, and when you pick from their bond funds, they actually offer what they call a low risk bond fund, a medium risk bond fund, and a high risk bond fund. And what's true about the low risk bond fund, it only holds bonds of maturities of 1 to 3 years, right? Short-term bonds. Medium interest rate risk bond funds hold maturities of 5 to 10 years. And then the higher interest rate risk bond funds hold long maturities of 15 to 30 years. Okay, so this is one of the things that managers of bond funds have to think about. What's the mix of maturities in my fund? Because the longer those maturities are, yeah, I'm going to get higher returns, but I'm also going to take a lot more risk. And then you have to think about the other, right? There's other risks of holding bonds. Obviously, default risk, right? Different bonds hold different risks based on who issues it, right? So, for instance, corporate bonds are riskier than treasury bonds because a corporation is much more likely to fail than the government's likely to fail. There's also the legal priority of a bond, right? Some bonds have preference in terms of who gets paid out in the event of default. And so those that are higher ranking in terms of priority are going to be lower risk. So default risk is obviously one of the big risks of loans. You also have to think about liquidity risk. Can you sell the bond, right? Can you sell it? Let's say that you need to sell it. Is there a market for you to sell it? This is a legitimate concern for many different types of bonds. For instance, municipal bonds. This is always a real concern. As we've talked about, municipal bonds, a lot of them are issued by local school boards, state and local governments. So it's not like there's a huge market for bonds issued by the Mount Vernon School Board. So if you buy a bond issued by the Mount Vernon School Board and then something happens and you need to sell it, you may not be able to, right? That's liquidity risk, and that's something that you're going to really have to think about before you buy that municipal bond. The municipal bond looks more attractive if you think you're going to be holding it till maturity. But if you think there's a possibility that you're not going to hold it till maturity, there's the liquidity risk there. And then finally, and we're going to talk about this here after in the next section, there's also inflation risk. Inflation risk is the fact that inflation can eat away the real return on holding a bond, all right? And so this gets back to our discussion of real and nominal interest rates, something that we talked about in Principles of Macro, but we will review here in a moment. So that ends section 2 of lecture. I'll come back in a moment here, and we're going to talk about real and nominal interest rates and inflation risk.